Friends, today I am now going to discuss metric representation of an operator. Means, how can we represent an operator as a matrix format? Matrix representation of an operator. So let's start discussion. How can we represent an operator? Suppose an operator A is an operator. How can we represent the operator in a matrix form? So what we can write? Suppose we have an operator, linear operator. Okay, we have a linear operator, that is A. A is a linear operator. It can be written as identity operator. Okay, it can be written as identity operator into A into identity operator. Identity operator means, suppose you are operating identity operator on a state ket psi, it will produce ket psi itself. That is an identity operator. So we can write a operator A as an identity operator, that is I. Okay, now I can be written as what? So suppose identity operator can be written as summation over iota equals, summation over I equals, not iota, I equals 1 to infinity ket phi I bra phi I. Okay, so we can write this portion as a operator equals iota operator, identity operator A, identity operator. Now identity operator can be written as what? Summation over iota I equals 1 to infinity ket phi I bra phi I, because we know these will result as 1. This product will result as 1 into A, and again this I operator, identity operator, I equals 1 to infinity. Now we have to take it as J, another indices. Here we have used already indices I. Here we have to use another indices, that is J, summation over J equals 1 to infinity ket phi J bra phi J. Okay, so operator A can be written as, Ij in the basis Ij, Aij bra phi I ket phi J. Yeah, I know it's quite very much difficult to understand. So now for you I am going to make it easier. So how can we, this is a format in which we can make an operator in the matrix form. So how can we make an operator in the matrix element? Suppose I have a matrix element of an operator Aij. So only remember this portion, so you can make an operator in the matrix form. Suppose we have an operator, we have an element of an operator Aij. It can be written as bra I A ket J, bra I A ket J, or you can write in this way also, we can represent this in this way also, bra phi I A ket phi J. Okay, so let's start taking an example. Suppose we have an operator A. Okay, so the matrix element of that operator can be written as, suppose we have a 2 by 2 matrix, A11, A12, A21, A22. So we can write it in a form such that A11 can be written as bra phi 1 A ket phi 1. A12 means bra phi 1 A ket phi 2. A21 bre phi 2 A ket phi 1 bre phi 2 A ket phi 1, sorry, ket phi 2. So this is a metric representation of an operator. Means when we are suppose we have an 3 cross 3 matrix, we have an operator, we can represent it in a 3 cross 3 form. So we can write here as 1 A bre 1 A, sorry, here it will be 1 bre 1 A ket 1 bre 1 A ket 2 bre 1, sorry, bre 1 A ket 3. Okay. Similarly, in this way we can write all these rows and columns. Suppose here we can write as 1 1 1 2 1 3 2 1 2 2 2 3 means bre 2 A ket 1 bre 2 A ket 2 bre 3 A ket 3. In this way we can write. So this is how we can represent an operator in the matrix format. So let us take an example of metric representation of an operator. Suppose we have LZ matrix. We know that whenever LZ acts on the spherical harmonics YLM, it will produce what? It will produce MH cut LM. We can write in this format also. Let me write clearly. We are just taking an example. When LZ is operating on L, M, it will produce MH cut LM. Now suppose we have orbital angular momentum L equals 1. So M values are 1, 0, minus 1. So let's construct a matrix using that formula of LZ. So now first of all, here we will write LM. LM basis means L equals 1, M equals 1. L equals 1, M equals minus, L equals 0, M equals 0. Azimuthal quantum number 0. We have got what? We have got L value, that means orbital angular momentum quantum number L equals 1 and azimuthal quantum number 0. Okay. Secondly, L value 1, azimuthal quantum number minus 1. Similarly, here we will write bre 1 ket 1, bre 1 ket 0, bre 1 ket minus 1. Okay. So whenever LZ is operating on this state, here this one is L. Let me change the pen color. So now we will write. Now you can understand by changing the pen color. Now this is L value, orbital angular momentum. This is M value. Okay. This is L value. This is M value. So whenever LZ is operating on this state 1 1, so it will produce one H cut. Okay, one H cut. So 1 1 LZ 1 1. Similarly, here we can write here as here 1 1 LZ 1 0. Let us write clearly. So whenever we'll write the matrix 1 1 LZ 1 1. Similarly 1 1 LZ 1 0. In the third row it will be 1 1 LZ 1 minus 1. So similar way we can, let me write in a big space, otherwise it's not fitting here. 1 1 LZ 1 1 1 1 LZ 1 0 1 1 LZ 1 minus 1. Similarly here it will be what? Similarly here it was 1 0. It was 1 0 LZ 1 1 1 0 LZ 1 0 1 0 LZ 1 minus 1. Similarly here it was 1 minus 1, so 1 minus 1 LZ 1 1. 1 minus 1 LZ 1 minus 1 LZ 1 0. 1 minus 1 LZ 1 minus 1. So we can write properly. So let's calculate the element value. So whenever we write 1 1 LZ 1 1, LZ will act on 1 1, so it will produce 1 H cut. So 1 H cut means what? 1 H cut means H cut 1 1 1 1. It will produce H cut. Similarly, whenever LZ will produce 1 minus 1, so it will produce what? LZ minus, here M value is minus 1, so it will produce minus H cut. But after exiting from the bracket, 1 1 and 1 minus 1, these are orthogonal, so this will be 0, so this value will be 0. So let's construct that matrix of LZ. So here it was 1 1 1 0, here it was 1 1, here it was 1 0, here it was 1 minus 1 1 1 1 0 1 minus 1. So here it will be H cut, here it will be LZ is acting on the 1 0, LZ acting on the 1 0 means it will produce 0 H cut, 0 H cut, so 0. LZ is acting on minus 1, so minus H cut, but 1 1 and minus 1 1, 1 1 and 1 1 and 1 minus 1, these are orthogonal, it will produce also 0. Similarly LZ will act on 1 1, so it will produce H cut, but 1 0 and 1 1, these are orthogonal, so it will be 0 also. 1 0 1 0, here 0 H cut is producing. Similarly here it will also 0, here it will 0, here it will also 0, but here it will be minus H cut. So matrix LZ will be such that H cut 0 0 0 0 0 0 0 minus H cut, or H cut 1 0 0 0 0 0 0 0 minus 1. So what's the conclusion? So what is actually conclusion? We will discuss that. So whenever we will write an operator in the matrix form, so it will be write in a way such that each element will act as a matrix element. So suppose we have, that means suppose we have an 2 by 2 matrix, so you can write it as 1A2, and write it as 1A1, 1A2, 2A1, 2A2. So this way we can construct 3 by 3 and n by n matrix. So thanks. So that is it for today. Thanks for patiently watching. So this is a process. We will construct a matrix or matrix represent. We can represent matrix. We can represent an operator in the matrix form. So thanks you for today, and thank you for patiently watching. Bye.